Hey, what's up everybody? Welcome to the outside open garage video series. RWG-OSD. Oversized Delta.
Hello, you have reached Russ Grease with RWGResearch.com. Open-source-energy.
Hey, what's up everybody? Yes, I am in my backyard. This is my backyard. It's basically a giant hill that's about 100 feet tall. And then my house, so hopefully there's no mudslides in the next couple of years. Anyway, I'm outside and I'm basically trying to do some more printed circuit board cutting. So as you know, I've done this once. I did it with my little Dremel. This is actually called a micro die grinder if you want to look them up. This particular model I couldn't find, but there's other similar ones. Can't say if they're any good, but they're about 40 bucks on Amazon and you can find them elsewhere. So what we're going to do is we're going to try this again. Now in the meantime, okay, I'll show you what I've actually been doing, and that is really trying hard to etch circuit boards. Okay, so I've etched these circuit boards. I drilled that one just to test it out, but you can see, there you go, you can see through there. Okay, that's actually an etched circuit board. So what I did is I took marker and I colored this thing and I etched this, and you know, to be honest with you, it turned out okay. But at the end of the day, I really want to go back to the cutting, okay, which is what I did with this one. Now I've figured out some things, and I tried to tell you this in the last video, and basically I figured out that I was trying to calibrate points and reconfigure the printer, and it was actually throwing everything off, and actually pretend like taking a flat piece of paper and sort of stretching it a little bit, and one side was stretched and one side wasn't, so it didn't quite work very well. However, since then I've figured it out. I've also ordered some new bits for cutting instead of trying to make my own. Granted, these may not work very well because they're 15 degree sloped points, and basically what that means is that's just such a small tip that I'll be able to go down a little bit further and not have to worry about it. But at the same time, kids are knocking on the window, but at the same time, I think what's going to be nice about this is that it's very sharp. I know it's going to be spinning the right way. I think it's going to be spinning the right way. No, I'm not even sure about that now that I look at it. Yeah, well, anyway, I don't think that Dremel tool has a reverse on it. Maybe it does and I just don't know it. Well, anyway, we're going to give this a shot with these very different sharp bits. They might be too pointy. I really, you know, I looked online and they said 60 degrees is the better. The tip won't get as hot. It's a little more sturdy. I might just burn the tip off this. I don't know. So, that is the plan. So let me show you the setup that I've got, because I made things a lot easier for me as far as alignment. Don't forget, I'm doing double-sided circuit boards. What that means is everything must be aligned perfectly when you flip the board, and that takes a lot of extra time and effort. Single-sided board, I'd have been done a long time ago. I'd have figured it out, but that's not the case. So let me show you what I did. Oh, welcome back everybody. So here it is. This is the thing that I made to make my life a little easier. This is a piece of PMMA, aka acrylic. This actually came out of a monitor, a flat panel monitor, and the reason that you can tell it is because it's got these little white dots all over it. Yeah, you can see those white dots. Those white dots are actually a color gradient, and it spreads the light out, but that's not, we don't care about that in this case. But anyway, what I did is I took it and I machined, as you can see, I machined an offset in here so that my circuit board find one. My circuit board sits inside of there. Now it cannot move. Okay? And then when I get this thing in focus, maybe. There we go. So when I get this made, I can just flip it and it goes right back into the same spot, okay? Now also on this board you can see these 4 black dots. Those 4 black dots are 90 millimeter holes. Okay, I put 90 millimeter dots markers on there, and what that allows me to do is when I start my process, I'm going to run this and actually get each one of those centered with the tip of my cutting tool, or in this case an ink pen if I'm going to be drawing. And I'm basically going to, you know, exactly align this thing with the 000 point of this machine. I forgot to actually mill a center point, and so I don't have a center point. That's fine. We could use all 4 of these to get it lined up. So that's my jig. I'm clamping this down using these clamps right here, and trust me, these suckers are strong. This thing does not move anywhere, even with just 2. So yep, that's what we're doing. That's how we are squaring up everything, and that's a long-winded way of saying I made a nice jig that holds everything in the center. What's up? We're back. So I've used one of my old boards and I just did some testing. It's quite hard to see, I understand. But at the end of the day, I think we're okay. So I'm not going to run the whole thing. I put 3 strips of tape. Okay, I think that was plenty to hold this in place. I'm going to go ahead and try cutting my last board. I only have this one left. This is it. I think this will work. So we'll give it a shot. But I have some more circuit boards. They're thicker. I bought a 12 by 12 sheet so I could cut it. And if I cut it myself, it's going to be hard to get in there so precisely. So I'm hoping this one works. I think it looks good. I think I'm going to cut it slightly deeper just to make sure it gets through the traces. I still think my tool's running the wrong way, but at this point, I can't do anything about it. So let's give it a go. Okay, so I told you guys I'm setting these to a calibration of each point, so I'm going to sort of run you through what I did. I just put a code in there to go to -90, +90, in both X and Y directions. So right now it's at, I guess it was at -90Y, now it's going to +90Y. Okay, and now it's going to go to, I think, -X90, and back over to +X90. And this does this, I think I put in here 4 times or something, 3 times. And this is just, you know, so I can double check the calibration. I do this before I flip the board as well, although I wouldn't move it probably. So anyway, that's basically what I did to make sure everything was squared away and zeroed. Alright, wish me luck everyone. This is the final cut. Get it? The final cut? Anyway, here we go. Alrighty, so I programmed in the code to basically go up to 300 and sit, so I have enough room to work. So it's done. I wasn't out here watching it, so there's a little section that wasn't quite deep enough right there. I think we can deal with that. I think most of it's good. It's just that one little corner right there. I cut it a lot deeper than I was cutting the trial piece, but I wanted to just in case. So, all right, let's take it off and see what we got. Alrighty then. There is my printed circuit board. So I've taken a razor blade and I've scraped it this way with the blade like this. Got rid of most of those burrs and then taken a brass wire brush and, you know, kind of going at it like that. And I think I got a little work to do to check all the traces, to be honest, and I will do that. That one section right there just didn't quite cut all the way through, but I think it's like the lines are scribed, so I can just sort of take a knife and cut those. I'll deal with that. I can handle that. Look how good that turned out, though. Here I cut it a lot deeper on the bottom. Here it was about the right thickness, depth. And then on that one spot, you can see it got a little light. I don't know really why it did that. Probably bumping this, or something didn't seat right, or this is lower on here. I don't know. Let's do the other side. I'm pleased with that. Well, one thing's for sure, I'm probably going to find an electric alternative because this is ridiculously loud. I can walk halfway down the street and hear it. Oh. Oh my goodness, that's freaking loud. We did it. It's done. Now, just gotta hope that it's all right. Let's clean it up. Well, if you can't tell, yeah, I've tried this a few times. I'm using all of my extras as coverings so I don't get shavings everywhere. There's even one down there. These are just the ones I had sitting around. All right. Yeah, oh my. Well, here's what it looks like before I go cleaning it up. Let's get you a close-up. It's actually not bad at all. So that's before I cleaned it up. Let's also get a shot of the microscope before. Let's just go down into here. It's pretty messy. So it's pretty messy in there. So let's scrape it up, clean it up, and then we'll look at it again.
Ah, moving so fast.
Okay, well there's what it looks like cleaned up. It's not bad. It's not bad at all. Even those little intricate holes. Look how good those little intricate holes turned out. So this side's a little bit deep, but I ran too high on this side, and I guess I'd rather be at a little deep. So here's what it looks like cleaned up. That is not bad, boys and girls. That is not bad. Part of that is due to the tip being so pointy. I can actually go a lot deeper without having to worry about burring up the traces too big, which, if you don't remember, last time it was pretty rough. Real rough. Now the question is it lined up? Now, some of you are going to ask me, Russ, why don't you also use this to drill the holes? That requires a whole extra set of effort. And I can just drill it by hand a lot faster. By the time I set the machine up, get that thing running, get all the holes made, switch out the tools each time, nah, I'll just drill it by hand. Let's see if I can get a good shot of this. Gotta get it focused. And there you go. It's hard to tell, but they look pretty lined up. I'll go ahead and drill some of those holes out and find out for sure. Ah! Wow. Let's find out if the holes are lined. Let's pick the smallest ones right there. This is what they look like on this side. And this is what they look like on this side. So yes, they are about as lined up as they're gonna get. I am satisfied with that. A little bit more to do, but that's for another time. Just got real windy. Okay, I took my razor blade and I just cut these. I cut them off. Lots of wind. Anyway, success. 3 printed circuit boards with holes drilled. Yeah. Say that's a success. Come on. There we go. There we go. Alright. So there it is. We are completely done. Well, we're not completely done. We're done with drilling for the most part, except for the other 3 holes. Ah! This was like almost a month's worth of work due to trial and error, and learning curves. Alright, well, it's getting windy, so if everything blows away, I'm going to clean up. Yeah! Leave a comment, let me know what you think. Wow. Yeah. You know, sometimes you got to work where you need to work. Today, it's the back of the house. It's the furthest away from neighbors I could find. That thing was freaking loud. Okay. Oh, welcome to the outside places where I am standing right now. This is actually a microphone check. Now you probably heard that. This is actually my backyard. No, I'm not kidding. How does it sound? I'm whispering in the corner all by myself. You can see me over here. Okay, enough of the mic check. Steve! Ah! Alrighty then, so check it out. This is what I got. Alright, this is just a piece of PMMA. No, it's gosh darn it. Oh, let me think of what it is and I'll start over.